Hello. I'm going to continue on with 11.2. Just going to kind of power through a few of these if I can. This one here, this is pretty simple, but you gotta know to test for this. If you just take the limit of this inner term here, this is the sequence here, an. If you just take that limit, you'll see that it's 1/3, and immediately you can know that this series diverges. So the idea is that if you have any old series with an there, if the limit of an is not equal to 0, then the series diverges. That's the divergence test. Okay, so we just immediately look at this and just say, alright, the limit n minus 1 over 3n minus 1, that's equal to 1/3. Why is it 1/3? Well, the powers are the same here, and so I just extract off the coefficient in front of n here, that's the 1, and the 3 in front of that n, that's 1/3. If you like, you can use L'Hopital's rule, just view the n as a continuous variable, as if it was x. And so you get infinity over infinity, take the derivative, there's a 1 up there, take the derivative of the bottom, that's a 3. Either way, you get 1/3, which is not equal to 0, and so that means that the series that we were interested in diverges. Okay, easy enough. Same thing for number 30, but for number 30, it looks a little more confusing, a little more intimidating. You really just want to focus in on the powers of k. Okay, so in the numerator here, if I were to multiply it out, I would get a k squared. That would be the highest power. So there's a highest power of k squared on the top, and on the bottom, if I were to multiply that out, the highest power would be k squared. So there's a pair of k squareds, and so we just extract the numerators, and taking the limit as k goes to infinity, k plus 2 over k plus 3 squared. Again, you get infinity over infinity. You could use L'Hopital's rule for that. However, if you just notice that they both have k squared as their highest powers, you extract the coefficients, that's 1 over 1, which is 1. So, and all I care about is that that's not equal to 0, and so therefore this diverges by the divergence test. Okay, number 31, a little intimidating because it's got powers that have variables in the power, so it's always a little bit uncomfortable. Okay, so there's our series. What I recognize here is that there's really two geometric series. There's this one and that one. So I'm going to first rewrite this as 1 over 3 to the n plus 2 to the n over 3 to the n. That's the first step. Then I'm going to separate this into two series. There's 1/3 to the n equals 1 to infinity, plus 2/3 to the n equals 1 to infinity. So I want you to notice that this isn't exactly in the geometric series form. We have the 1 to infinity, but this is usually n minus 1. So the trick to deal with that is let's pull a 1/3 out. I have 1/3 times 1/3 to the n minus 1. And then I have 2/3 times 2/3 to the n minus 1. Now that is in the geometric series form. It's a r to the n minus 1, n equals 1 to infinity. That's equal to a over 1 minus r, as long as r is less than 1, the absolute value. And we have that in both these cases, so let's just go straight for the formula. The a in this case is 1/3, and then I have 1 minus 1/3, 1 minus r on the bottom. And then here I have a is 2/3, and I have 1 minus 2/3 on the bottom. Let's finish that up. This is 1/3 over 2/3, so it's equal to a half. And then here I have 2/3 over 1/3, that's equal to 2. So I have 5 halves. That's the final answer. Okay, get another chance to practice that. Let's do number 32. I have 1 plus 3 to the n over 2 to the n. So this is equal to the summation of 1/2 to the n plus 3 halves to the n. N equals 1 to infinity. N equals 1 to infinity. Okay, now here's what we notice on this one, is that this r here is equal to 3 halves, which is greater than 1. So this diverges. We don't even need to continue. The limit doesn't equal 0, right? Just that alone, the limit here does not go to 0. You could actually do the limit here and see that, but it's a little harder. Maybe you're less comfortable with that. But if you're interested in doing that, you just take the limit of this. You could use L'Hopital's rule. You get infinity over infinity. Take the derivative. You get 3 to the n, ln 3 over 2 to the n. Actually, it doesn't really. You could do that, but anyway. Once you have it in this form, it's in a geometric where the r is bigger than 1. So it diverges. Let's continue on. So look at number 35. ln of n squared plus 1 over 2n squared plus 1. Okay, kind of fancy looking. Take the limit here. Okay, just the inside here, this limit goes to 1/2 because the powers are the same. I just extract the coefficient, so it's 1/2. That's the inside. So if I take the limit as n goes to infinity of that whole thing, the inside goes to 1/2, so this equals ln of 1/2, which I don't care what that is exactly. I just know it's not equal to 0, and so this diverges. Number 36, n equals 1 to infinity, 1 over 1 plus 2/3 to the n. Okay, so here, again, let's just take the limit. That's the first thing you should always do when you investigate these things. You have no hope of convergence unless this limit goes to 0. So let's start with that. Limit as n goes to infinity is 1 over 1 plus 2/3 to the n. Now, as n goes to infinity, this 2/3 to the n, this goes to 0. So that equals 1, which is not equal to 0, and so this diverges by the divergence test. Number 37, we have pi over 3 to the k. This is a geometric series, but you have to realize, pi is 3.14, right? So pi over 3 is greater than 1. So this diverges because we have r is bigger than 1. Number 39, we have arc tan of n. Put a little parentheses around that to emphasize it. N equals 1 to infinity. Let's take the limit. Limit as n goes to infinity of arc tan of n. Well, this is pi over 2, which is not equal to 0, and so this diverges. Now you might be sitting there wondering, why is it pi over 2? Well, a couple ways to look at this. First of all, the graph of arctangent is one that's worth knowing. It comes up a lot. This is pi over 2, negative pi over 2, so the limit as x goes to infinity of arctangent of x is pi over 2. You can see that from the graph. And the limit as x goes to negative infinity of arctan of x, that's negative pi over 2. Okay, so that's one way to know that. But I'm just showing you this because you should know this going into any exam, that the limit of arctan as x or n goes to infinity is equal to pi over 2. If you notice in the book, it's a red numbered problem, this one here. So it's a good one to know.